Sorry, I've just been informed that there was no sound, was it? Just now during the video.
Yeah, no sound, no sound.
Oh, okay. Let me try again, I guess. Give me a second, yeah.
The world is getting more complex. Life is changing, and so is learning. Students and teachers in a classroom are now faces on a screen. Attention spans are shorter, and workloads are bigger. For teachers and learners, the struggle grows while inspiration is lost. But what if we could bring back what learning is really about? The spark of curiosity, the unshackling of ideas, the pure pure delight of discovery. Learning feel more like play than work? Where things that are taught resonate with the needs of every learner. Where virtual learning doesn't just imitate the classroom, but brings new possibilities. Where the content adapts as lifestyles evolve. This is learning simplified. We understand the challenges teachers and learners face, and we are here to help. In over 85 countries, we are transforming education with one goal in mind: to bring back the joy of learning.
I was a teacher for 5 years. I enjoyed my daily interactions with my students the most.
Making a positive difference to life. That's what education is all about.
The most satisfying thing is helping others to improve.
Good education can change lives, and I'm passionate about being a catalyst for this change.
Education is a great way to preserve culture and language.
Over 60 years, MCE has worked with ministries, educators, and parents in 40 countries in over 7 regions and 11 languages to design research-based educational solutions.
We will do a quick introduction and introduce Brandon as our esteemed specialist of Marshall Cavendish, and then we'll proceed to the presentation.
All right. So thank you, Sanja. Good morning, everyone, and welcome to the fundamentals of Singapore mathematics approach. It is a pleasure to have everyone here today. Just a note, can the people at home on Zoom change your names? Because right now you're all registered as Sanja, if you don't mind.
Okay. So let me quickly introduce. So today we have with us on the Kazakhstan side all the brilliant teachers from different schools, top schools in Kazakhstan come here today. We have about 50 teachers attending all in all, half in online and half in offline. Hi, everybody. And we also have the other side, which is on the Zoom side. So on the Zoom side, we have Marshall Cavendish team. Lydia will be helping us today with the administration stuff. And Mr. Brandon, let me introduce Mr. Brandon. Mr. Brandon is a top Marshall Cavendish specialist. He's a product expert. He's a curriculum expert. He does curriculum review work for different countries. They're doing all kinds of amazing work, Singapore math and science. So he is a teacher with a lot of experience. He's a master trainer, and now he's working for Marshall Cavendish on the curriculum side. So he is ideally positioned to give us an overview of Singapore math, to give us an introduction to Singapore math methodology. Thank you, everybody. So, Mr. Brandon, the floor is yours.
Thank you. Very good morning to everyone. First of all, just to share before we start that usually I would conduct my workshop all the time at home. So today, due to some unforeseen situation, my Wi-Fi was down and I don't have time to fix it. So I find myself now in a nearby cafe, and so I have put a maximum noise suppression. So I hope it works. And but what is going to happen today will go as planned. I'm going to share with you the important we call it the fundamentals, or simply put, I would like you to know what is Singapore math about. I think that's what you're interested to find out for today. Okay, so I would like to share my screen now. Okay, so I understand that some of you do not speak English and there is a need for translation. So I will do it slower, and I will pause every now and then for you to translate. Okay, if it works.
Yes, thank you, Brandon.
Yeah,
that'll be good. All
right. So okay, so I guess I don't have to introduce myself anymore. Sanza has already shared with you. So before I start, just to share with you that because of my experience, I'll be able to share experience that you might be interested to find out inside the classroom, outside the classroom, how our school works, how we teach math, okay, our teaching resources. Now, all these questions regarding these areas, you can ask me. I'll be able to answer you. And so, yeah, let me pause for a moment. Sanza, would you like to?
Yeah, sure.
Give me a prompt when you need to translate.
Yeah, sure. В общем, если есть какие-то вопросы по в целом, ну, во время презентации, в конце презентации, по вопрос, например, как в сингапурском классе, да, в школе это проходит и так далее. То есть по любым таким вопросам он будет рад ответить во время презентации. Yeah, thank you.
Okay, so let's start. Now, what is Singapore math about? So you might want to know. Singapore math, actually, the fact is that there's no such thing as Singapore math. It's not like our math is very different from other countries. Mathematics is a universal language, it's a universal subject, right? Everyone is probably learning the same thing. But why this label, okay, or about Singapore? So it must be something to do with how we teach. We teach differently, and I'm going to share with you on that.
Yeah, we can continue. Yeah.
Okay. So let me share with you some background. All right. So a quick one. Singapore, we have been doing well in math, okay, based on the good results in Kim, PISA, all right, PISA, and in fact, there's a history behind our mathematics performance. Okay, actually in the 70s, 60s, 70s, even beginning of the 80s, we were doing pretty, low in our performance, comparable to those of our neighboring country in the Southeast Asia. All right, there are 3 tiers in, let's say, TIMSS. Of course, PISA came out much later. We are always at the lower tier. So in the 80s, all right, our Ministry of Education, okay, gather all the experts, all right, and we try to come up with ideas how we should change our way of teaching. What can we do to help our students learn mathematics? So there were changes in the textbook, the changes in how we teach. All right.
Извините, пожалуйста. Sorry. There is some echo. I don't know.
Yeah.
There's no. Brandon, do you hear echo from our side, from the room?
Not really. I don't hear echo from you, Sanza.
Okay. Окей, это значит на вашей стороне должно быть, потому что с нашей стороны эхо нет. Okay, yeah, we can continue. It's a technical thing.
All right.
Yeah.
So basically, due to our changes, in how we teach, even how we test our students, right? We have made improvements over the last 20 years, okay, 10 to 20 years, and it has been progressive until today. Okay, we update our curriculum, we update what to teach and how to teach, and so we see results, right? And because of that, I think countries around the world, they are interested to find out, okay, what is happening in Singapore? How did we, students of Singapore, get to perform better than the other countries, right? So because of that, some of the countries adopt the books, find out what we teach. So experts like me will get to go around the world to share. All right. So there are 2 key features of the change, okay, in Singapore math. Number 1 is that introduced in the 90s, there's this mathematics framework, okay, which I'm going to share with you. And of course, something that is uniquely Singapore, the bar model method, which was developed in the 80s, but of course, all these actually rolled out in the 90s. So As you can see, we are 2022 now. There has been 30 years of application of what we are trying to change, and so we are sharing with you our 30 years of learning curve. All right.
Thank you, Brandon. So quickly, небольшой такой бэкграунд, да, вот вообще почему сингапурская математика, да, большой вопрос. Зачем нам это надо, зачем нас это интересует? На самом деле, сингапурская математика сейчас очень стала известна по всему миру благодаря различного рода тестированиям функциональной грамотности. Может, слышали про PISA, про TIMSS. Это разные тесты для детей начальных школ и среднего звена. Там дети от 8 до 15 лет тестируются по всему миру. Это делается с простой целью, чтобы определить, какие системы образования, какие методики преподавания являются самыми эффективными в мире, чтобы мы все как сообщество, глобальное сообщество мира могли учиться друг у друга. И это в таких тестах Сингапур постоянно выходит впереди. Первое, второе место, они постоянно меняются местами, но поэтому весь мир как бы сейчас интересует, что за методика. То есть Брэндон рассказывает, что буквально там 30-40 лет назад Сингапур на самом деле был очень внизу по этим тестам, да, то есть математика у них отставала и так далее. То есть как раз Сингапур это очень относительно новая страна, и буквально, так, если не ошибаюсь, с 65-го года они, то есть 50 с лишним лет, 57 лет, да, им. То есть их системе образования, реформам в преподавании математики буквально 30-40 лет. Вот за последние 30-40 лет они проделали огромные рывки. То есть он рассказывает, что именно благодаря этой методике и используя математику как ключевой предмет в системе образования, они смогли сделать рывок, в том числе и экономический рывок, да, в своей стране, то есть в технических специальностях, исследований и так далее, и так далее. Вот как раз поэтому такой вот бэкграунд, почему мы с вами здесь и собрались, почему мы в Казахстане, да, в Центральной Азии вообще интересуемся этим предметом. Thank you. Yes, let's continue.
Thank you. Now, let me share with you what changes were made first. Then I will share with you the framework. Yeah. So as I shared earlier, in the 60s, 70s, 80s, we realized that our students were not doing well in math. So we try to figure out what's wrong with that. And we have decided, right? We here refers to the educators in Singapore. We decided that we have focused the wrong areas. All right, we focus on the wrong areas. These are the 3 areas that I have identified, and then we did away with this. All right. So the first one was computation. Now, why is this focus on computation? Now, I have done work with other countries, and I see even today there are maybe countries or even your books in Kazakhstan. You might have questions like this. For example, let's say 0.1234 multiplied by 0.567. All right. Example. Now, in questions like this, even in Singapore, in the 70s and 80s, students were asked to do this kind of work. Now, this is a lot of computation, okay, long working, and then they'll start to work out, right? But in that change, we thought that this kind of question, a lot of computation, is going to take up students' time, and there's a lack of time for this, okay, or opportunities for the student to focus on thinking and problem solving. And you see that questions like this in today's situation, we have phones, right? We have calculators. We can easily find the answer, right, in a few seconds. So questions like this or content like this, to us, we find that even if the students can do it very quickly, it's not going to help them do well in the math. So we thought, okay, why not get the students work out tedious sum with calculations that are long. Let them do use the calculator, and let's focus on problem solving. So that's the first one that we did away. No more focus on computation. I will teach you how to compute, but I will focus on problem solving. Okay, so that's the first one.
Okay, let me translate that. That's a lot. Yeah, thank you. Okay. То есть кое-какие мисконцепции, потому что у всех у нас уже есть какое-то представление, да, наверное, что-то слышали и так далее. Первые 3 мисконцепции. Вот первую давайте обсудим. Упор на вычисление, вычислительную часть. Да? То есть на самом деле мы думаем, что да, вот ученик, который учится, например, по сингапурской методике, он там может в голове там что-то считать быстро. Да? То есть, но реалии сегодняшней экономики такие, что такого рода навыки, они на самом деле бесполезны на рынке труда и в целом вообще. Они не делают тебя креативнее, они не делают тебя как-то полезнее или продуктивнее, или не дают тебе возможность зарабатывать больше. То есть мне очень жалко, что до нас, до того, как маршал Cavendish и сингапурская математика появилась в Казахстане, прошла волна вот такой ментальной арифметики. Да? Но тем не менее, к тому, что сингапурская математика на самом деле не делает акцент на вычислительную часть, делается акцент на мышление, развитие мышления и решение задач. То есть решение задач – это более логика, более именно высшего порядка навыки. То есть на это делается больше упора. На вычислительную часть, да, мы этому обучаем, это необходимо, это навык низшего порядка, это механический навык, он нужен, но на него не делается акцент. Yes, let's continue.
Okay, so that's the first focus that we did away. Now, the second thing we saw, our students were learning procedures, were learning the methods of answering questions, right? And we noticed that the students they did not understand math actually, they just tried to remember how to do, right? For example, how do you change, right? This is a very common question, yeah? This is a mixed number, 2 whole, 3 quarter, all right? How do we change this to improper fractions? Now, many of our teachers will say, okay, you please do 4 times 2 and then plus 3, right? 4 times 2, 8, 8 plus 3, 11. 11 over 4. And then maybe some students may ask, teacher, why we do that? Then the teacher will say, wow, remember this is how you do it. This is a procedure, right? This is a procedure. So this is like just a way to find it. There's no explanation. So we've realized that students have learned math without understanding the math. So we have decided to do away with the focusing on the procedure. We still teach procedure, but we want to teach understanding. Right? We change the way we teach. We want students to be able to see it and know what they're doing. Okay, so Sandra.
Thank you. Вторая мисконцепция – это упор на процедуры или как процедуральное, да, поэтапное механическое решение или как алгоритмическое решение. Да? Например, у нас детей готовят там, к тестам, да, особенно или ЕНТ, или там НИШ тесты и так далее. То есть фокус именно идет на процедуральное, то есть алгоритмическое решение. Вот здесь вот так вот знаменатель сюда переставишь, вот так решишь, все, ответ нашел, все, давай, решай следующий. То есть, но опять, то есть суть не в этом. То есть упор идет не на умение просто быстро как бы переставить что-то. Да, это нужно, это ребенок должен научиться делать, но опять упор не в этом. Это не есть цель, то есть это не есть сама цель. А цель, чтобы ребенок понял, почему, например, когда мы берем смешанные числа, вот как пример, да, здесь, почему мы делаем именно эту процедуру, да, почему мы делаем именно этот этап или этот степ. То есть для этого как раз-таки в сингапурской математике много упора на визуальную часть, то есть диаграммы используются, бар-графы и так далее. То есть все это помогает визуализировать и разного рода конкретные прикладные материалы, которые у нас там сзади есть в кабинете. То есть это все помогает донести суть и объяснить вообще логику, да, детям.
Okay.
Yes, thank you.
So now you may wonder, oh, if you don't teach it this way, how do you teach it? How do you teach for understanding? Now, for example, right, 2 and 3 quarter, we will show it this way, 2 and 3 quarter, right? We'll say, okay, can you understand or can you see what is 2 and 3 quarter? So we will have 1, 2, let's say I use circle, right, 3 quarter, this will be 3 quarter, right? I shade 3 quarters and then I shade 2 circles, right? Now, in order for students to understand, what is improper fraction, that means they will have to see how many quarters are there. So we will explain to the students that, okay, please cut it into equal parts. Cut it into equal parts. All right. Now, don't forget, these are young students. They are primary kids. So they need to visualize. That means they need to see and they need to understand what they're doing. So when they can count, all right, 1, 2, 3, 4, and so on, they are all together 11 quarters. Okay. So we will teach this, right? From here, a mixed number, how it looks like, and then how you get the answer. Right? Only finally, last, then only we will teach this one. This is the last step. If you want students to do it very quickly, we teach the procedure. The difference is that last time we only teach procedure. Now we teach understanding first, then procedure later. Right?
То есть, ну, пример довольно сам себя объясняет. В целом, опять идет упор на визуализацию. То есть сперва мы должны детям объяснить, да, визуально, что мы подразумеваем под целыми и под частями. То есть здесь мы будем, например, делить, у нас будет 2 целые и 1/3. То есть мы делим каждый из этих кругов на 4 равные дольки и потом закрашиваем. То есть мы даем детям возможность самим это все нарисовать, закрасить, повзаимодействовать с этим материалом. Да? То есть, и потом мы даем им возможность все это посчитать и прийти к выводу, что это 11 частей, то есть из 4, да? То есть 1/4 получается. И только потом мы возвращаемся к механическому, скажем так, алгоритмическому методу, но только пройдя через вот это все, когда мы уже уверены, что ребенок достиг мастерства, что он понял эту концепцию, мы его обучаем более легким способом, да, коротким способом. И он говорит, что 30-40 лет назад, когда они вот только-только получили независимость, они тоже преподавали вот так сперва. Упор на тесты, упор на как бы решения, да, именно чтобы найти ответ. А сейчас они много времени акцент уделяют сюда и только потом передвигаются к механическим методам. Спасибо. Thank you.
Okay. So the third one, we realize that we have focused too much on rote memory. I think it is very common. Students like to remember. And sometimes I'm sure some teachers will say, you don't understand? Don't worry. Memorize first and think about it later. So there has been this traditional practice that we want students to remember even without understanding. So we want to now shift the focus. Get no more rote memory. You will remember if you understand. Right? So for example, let's say multiplication table, right? Now, multiplication table, let's say, over in Singapore, our grade 2 and grade 3 students will learn multiplication table. Now, if I ask a student, what is 9 times 8? How would the student answer? Most of them will try to recall. Maybe some teachers ask them to sing songs. Oh, 9 times 1, 9, 9 times 2, 18. And they have been doing this. Now, this is just rote memory. If you ask them, what is 9 times 8? They cannot really see it. They can't really see it. They will just remember it like a song lyrics. So, while of course it is good to remember, but we want students to understand, we will show them, oh, 9 times 8 means I have 9 sets of 8. So this is 1, 2, 3, 4, 5, 6, 7, 8. So I have 9 sets of them. 9 sets. All right. So that is what we want to focus. We want students to know. Don't just memorize. Do you know what you're reading? Do you know what you're memorizing? How does it look like? So it looks like this. And let's say 9 times 8. Many students, if they just based on memory, they will forget. Even adults, we sometimes will forget. Yeah. If students forget, then what are they going to do? They will give up. Oh, I don't know. I cannot remember. You see, math is not about memory. Math is about knowing, understanding, and then apply, right? So if you cannot remember, it doesn't mean you don't know how to do math. You still can do math. It's just that you cannot remember. It is different, all right? So then what do we encourage students to do? We want them to see. So those students who cannot remember what is 9 times 8, let's say, they can visualize, right? 9 sets of 8. So say they know what is 10 sets of 8. because 10 is the easiest to remember in the times table. 80 here. You have 10 sets of 80. 9 sets of 8. Okay, so that means, let's say I have 10 sets. Okay, so here to here, let's say now it's 10 sets. If I want 9 sets of 8, all I need to do is to take out 1 set. If I take out 1 set, I will have 9 sets. So what the children can think about is, oh, I just take out 1 set, I can get 72. Now, students who are able to think this way, they now can see, oh, 9 times 8 actually means this. And even if I have forgotten, I've forgotten the lyrics, I can still figure out. Even if I don't have to count one by one, I can have strategies to work out. No problem. So now math becomes very fluid, very easy, because it's not just remember. You can actually understand and choose the way you want to answer the question. So that's why we no longer focus on rote memory. Okay.
Thank you. Ну, давайте разберем этот пример. То есть третья мисконцепция – это упор на механическое опять. Rote memory – это просто запоминать, да, вот процесс или просто запоминать в голове, вот в памяти просто держать что-то. Хороший пример – это таблица умножения. Например, если полистаете книжки, в сингапурской математике они не учат сперва таблицу умножения. Они очень… Точнее, я вообще не видел, чтобы они прямо заставляли учить. Они просто решают много задач на вычисление однозначных чисел, там, умножение, деление и так далее. И ребенок уже как бы в контексте потихоньку начинает запоминать. То есть память, она вырабатывается со временем. Но у нас, я помню, меня как заставляли в 3 классе, меня просто выставили перед доской, да, нам дали домашнее задание, просто его выучить. Там, хочешь, не хочешь, там тебе дали просто одни выходные. И все, и мы стояли. Я не знаю, какой подход лучше, но здесь он имеется в виду, что именно в их методике нету именно упора на память. То есть мы, говорит, ничего сперва не зубрим, мы сперва пытаемся понять и визуализировать. То есть, например, такой пример они бы решили следующим образом. Сперва сделали бы, нарисовали бы какими-то кругляшками или фишками, да, дали пару поиграть и сделали бы 9 линий по 8. То есть 9 наборов по 8 или 9 групп по 8. Потом этот ребенок может сам посчитать, убедиться, да, найти ответ. Это первый метод. Другой метод более быстрый. Например, дети хорошо запоминают таблицу умножения 10. Это одна из первых, которую они изучают. То есть они могут сразу, то есть как использовать более логический подход. Да, вместо 9 они увеличат на одну 10, 10 на 8, 80. И они понимают, что нам нужно просто убрать одну линию. Да. То есть это уже более такой мыслительный подход на мышление. И учитель как бы помогает, позволяет детям через свой урок разные подходы рассмотреть. И вот так вот дать ребенку мыслить и прям почти как играться с математикой, да, скажем. Не просто зазубрил, дал, получил оценку, убежал, да, а вот именно играться с математикой, вертеть ей как виртуоз. И потом уже со временем, конечно, уже дальше, уже взрослый человек, он запоминает таблицу умножения. Я, может, не все сейчас вспомню, но в целом мы как бы все уже знаем, да, наверное, без таблицы умножения. Да. Не помните, вот, да. Ну, я тоже сейчас ничего не вспомню, но если прям напрягут, я вспомню. Not everybody here remembers the multiplication table. Yeah.
Okay. So yeah. So now I have explained to you what we identify as something that we have focused too much on and we did away. So now, in that case, what is that new thing that we introduce? Right? So okay, I will show you this one first. We focus on these areas, Singapore math. All right. First, no more focus on memorizing, doing a lot of long calculations, because you are not going to become a calculator. You are a problem solver, right? For our students, yeah. So we don't want them to be calculators. We want them to be computers, as in with a higher ability in solving problem and not doing calculations. All right. So we want them to think, and in order to achieve that, we bring in new teaching methods, which we call we incorporate the learning theories. Okay, actually there are many, but today I'm just going to give you some very basic and must have in our teaching, right, will be a list of this, which I'll explain later. The CPA approach, relational understanding, variation, and spiral approach. Okay, I will talk about it one by one. So the focus now is on problem solving, right? Problem solving. And okay, I will continue this one first, then I will pass to you, Sandra. Now, this is a Singapore mathematics framework that is simplified. So all math teachers in Singapore will have a look at this and remind ourselves what our focus is. So at the side here, it will be like the areas to cover, right? What areas of the mathematics to cover, what kind of attitudes, what kind of skills, problem solving skills, and so on. But what I want you to focus here is the center of it. You can see that the center of it is actually problem solving. So what it means is that while you are math teachers, you can teach all the math skills and concepts. Don't forget that your job is to not just teach mathematics concept. Your job here is to teach how to solve problems. Those that you are teaching, the concepts and the strategies, are just tools for the students. We need you to teach the students how to make use of the tools. All right. Now, if you remember, or you have an idea, like questions in PISA especially, there are a lot of real life situation and application. Those are like how to solve problems. And so in our schools, we don't want to just focus on the tools itself. We want the students to learn that skill of how to use that tools. All right, so that's our focus. Sansa?
Okay, one second. Yeah. Давайте теперь разберем уже поближе. В первую очередь, как он сказал, это упор на мышление, упор на решение задач, или problem solving на английском языке. Вот это является фреймворком сингапурской математики, это сердце сингапурской математики, как бы, скажем так, философии или принципы, да, здесь заложены основные принципы фреймворка. То есть и он акцентирует именно, что вот весь фреймворк, если разобрать, сперва нужно начинать с сердца, то есть с самого центра. Это решение задач или problem solving. То есть мы, как учителя математики, как учителя математики в начальной школе, наша цель на каждом уроке, цели нашей учебной программы – это научить детей решать задачи. Решать задачи разными путями, разными инструментами. И вот эти 5 по сторонам, да, это все инструменты или навыки, или способности, да, все, что необходимо для того, чтобы достичь этой цели, чтобы можно было решать математические проблемы. Yes?
Okay.
We can continue.
Now, so back to this one. The framework reminds us, right, that we need to focus on problem solving. And how do we achieve that? We need to change our way to teach now. Now, if our teachers go to the classroom and only teach students, oh, remember this formula, remember that, how to answer this question. If everything is just doing that way, or read the book, please learn what is in the book. That will be too challenging for the students to solve problem by just doing that, right? The idea is that if you want students to learn how to problem solve, or if they are able to solve problem and be problem solvers, they must first learn math by understanding what they're learning. All right, so understanding comes first. Method comes later, and with these two, whenever they see any problem, they will be able to combine the knowledge and solve that. All right, so what do the teachers do? We must first change our way to teach. So our teaching must focus on understanding, then on how to solve the problem. Okay, and to make that happen, we change our way of teaching. We teach in a way where we have these things inside: the CPA approach, relational understanding, variation, spiral approach, collaborative learning. Okay, let me explain one by one. All right. So CPA approach. Okay, maybe I will just use examples. Yeah. Okay, I will come to that. Now, I'm going to use these questions to get you understand what problem solving is, and then I will bring in the CPA approach. Okay, since we say, okay, we are not going to focus on computation and rote memory, we focus on problem solving. Then to you, what is problem? What's a problem? So this will be an example of a problem. Problem means something that students see, and at a first glance, I cannot tell you the answer straight away. I must think what this question is about. I must think what strategy to apply, and I must think whether what I'm doing is right. So there's a lot of thinking involved. So that is problem solving. By learning, yeah, okay.
Sorry, can we zoom in a little bit on the problem so everybody wants to be able to read it? Our screen is not that big, so just maybe like a little zoom in would really help.
How do I zoom in? This is PowerPoint slide. Okay. Let's see. So I will have to. Okay, maybe shift this a bit. All right. Then, when I come to the, hold on, yeah. So it doesn't work.
Yeah, maybe increase the size. Yeah, the whole thing.
Yeah.
Or leave it in PowerPoint view. It's also maybe. Yeah, it's still bigger, I think.
So let's see. I make it bigger here.
Yes.
All right. Yeah. Okay. Is it better now?
All right. Yeah, this is perfect. Thank you so much.
All right. Now, so for you to have an idea what problem solving means, perhaps you can try doing this. Now, one thing for you to take note of is this. In Singapore, for primary school, we don't teach algebraic problem solving methods yet. We teach algebra, but it's a simple, addition, subtraction, multiplication, simplify kind of algebra. Problem solving, that means equation to solve, is not introduced in primary school. But we still want students to work out this problem. So my challenge to you is this. Okay, try to understand this question and think of a way to find the answer. But you cannot use algebra. Are you able to do it? All right, let's try.
Let's see. Give us a little time. То есть, чтобы лучше понять, что такое задача или проблема в сингапурской математике, он предлагает нам попробовать напрячься мозгами и попробовать решить эту задачу, но условие, что алгеброй пользоваться нельзя. То есть никаких иксов, никаких игреков, забываем ЕНТ подготовку. То есть, потому что в сингапурской математике на самом деле начальной математики, именно в начальной школе нету такой формальной алгебры. Есть как бы немножко какие-то элементы, но нету прям иксов, игреков, нету уравнений в нашем, как мы это понимаем, да, как нас учили. То есть он предлагает челлендж для нас с вами, попробовать решить эту задачу без алгебры, какими-то другими путями. Уже решили? Здорово. Давайте я вам объясню задачу. Так, окей. Алан, наш главный герой, положил сахар на тарелку. Общий вес сахара и тарелки 110 грамм. Белла положила в 3 раза больше сахара, чем Алан, на эту же тарелку. И теперь общий вес сахара с тарелкой стал 290 грамм. Найдите вес сахара, который положила Белла на тарелку. То есть два героя. Алан положил сахар на тарелку, вместе с тарелкой весит 110 грамм. Потом пришла Белла, положила в 3 раза больше сахара, чем Алан, и теперь тарелка вместе с сахаром весит 290. Ага. Трайс, 3 раза. Ага. Теперь найдите вес сахара, который Белла положил.
90.
We have many different answers, so give us a second to consolidate them.
All right, all right.
What's your answer?
90.
180. Okay, in Zoom chat we have 99. Okay.
90, not just 90.
90. Okay.
90.
180, 90. Еще ответы. 90. Everybody got 90? Okay. Brandon, it's overwhelmingly 90 and one answer 180.
Okay, let's see. Now, the answer is important, but more importantly, how do you do it? Did you make use of algebra? Do you draw it out? What do you do it? I mean, how do you do it?
Yeah. Как решали? Какой метод использовали? Голове? Drawing. Oh, someone was drawing. Okay.
All right.
Drawing, yes.
So sorry, it is 270. I thought it was asked about Alan's one.
Okay, we will find out very soon. Okay, the brown sugar, the weight of the brown sugar, and okay. Now, how do we do this? Now, first of all, now this is problem solving. You realize that it is a problem solving because there is a situation given like this, right? A word problem. Students need to read and understand because it doesn't tell you, oh, please do 110 times 2. What is it? It's not like that. This is too simple, right? If I give you a question like this. But this is like words. Students need to read and understand what the words are telling. So problem solving will be something like this. Number 2, what should I do? Am I supposed to do 290 plus 110? Should I minus? What am I supposed to do? So you have to think, what does it mean when I plus? What does it mean when I subtract? Okay. Yeah.
Shall I translate?
Yeah, sure.
Okay. То есть он говорит, что здесь на самом деле главное не ответ, а метод решения. То есть как мы будем подходить к этой задаче. То есть разные методы, но, например, то есть можно в уме постараться решить это далее. Но говорится, самое главное, вот когда человек решает, когда он приходит к какому-то выводу, что нужно складывать, вычитать или делить, умножать, он должен понимать, почему он это делает, что он делает. Да? То есть не просто механически его решить, а конкретно понимать логическую связь между количественными характеристиками в задаче. Да? То есть именно что эти числа 110 и 290 представляют, и какими манипуляциями их нужно решать. Но главное, потому что механическая часть очень простая, да, то есть ребенок сможет спокойно вычесть или поделить и так далее. Но именно додуматься, что нужно сделать, логическую связь разобрать, вот это именно и есть самая сложная часть любой задачи.
Okay. Now, if you are the teacher and you say, oh, please read this and can you see is 290 plus this and minus that? Now, students will not be able to see because you are telling and they are imagining in their head. So we realize that the students must be able to see for themselves, right? Not just by listening to you telling them and imagine in their head. Therefore, we want to let them see it in the pictorial representation, in pictures, all right? Now, what do I mean by that? Okay, let's take a look. Okay, as you can see here, we use pictures to represent, all right? And yeah, by the way, the answer is 270 for those who are interested, but I think I would talk about the method more, yeah? So what is this? This is actually pictures. Now, how does it work? Okay, maybe I show you step by step. First, Alan put some sugar on the dish. So you have 2 parts here, right? 1 part dish, right? And 1 part sugar. And then this will be 110. Now, if you are just telling the students to see it in their head, it doesn't work because they cannot really see it in their head. They have to draw it out. Now, this is what we call the bar model. Bar model is a pictorial representation That means I'm going to represent the information in the forms of picture. Of course, I'm not going to draw bows. It doesn't really help me. I draw bars and use the numbers to represent the bars, then it will help to see. And then another situation, another person, Bella, put 3 times the amount, and you can see 3 times. All right? So because you draw in proportion, you are able to compare and say, because this is 290, I will be able to see that here to here will be 120. That means two sets of sugar, right? 2 times of the sugar is actually 180. Now, so we will also have workings like this to support. Okay, we use the word units, for example, because we don't know, it can be a bowl or it can be something. So just units, 2 units of the sugar is 180, 1 unit of the sugar is 90, 3 units of sugar is 207. And this is the answer. Now, this is an example to show you what problem solving is. And number 2, this is what we call the CPA approach, right? CPA. Now, C stands for concrete materials. For students to learn new concept, for example, we try to bring in the actual items for the students to see, to understand what they're doing. And then we turn it into a picture. So this is the pictorial. The P is actually the bar model, the pictorial. And A stands for the abstract representation, the numbers, the words, right? So in our teaching of math, we try to bring in the CPA approach, give students the actual material, show students the bar model, even for problem solving, and then only they do the working in abstract. All right? So this example, I'm actually telling you what CPA is and what problem solving is about.
Awesome. This is a great explanation. Let me try to quickly elaborate.
Okay.
То есть, как мы ранее сказали, то есть вся суть в методе решения, да, то есть, но перед этим еще нужно задачу разобрать. Так вот, в сингапурской математике большой акцент уделяется именно визуальной части, то есть моделированию задач. Называется modeling или problem modeling, то есть моделирование задачи. В данном случае это bar modeling, то есть использование плиток для изложения условия задачи, скажем так. То есть это позволяет визуально ребенку очень конкретно понять взаимосвязь между этими числами, этими количествами, помогает выстроить логику решения задачи. То есть когда это правильно изложить, разрисовать, смоделировать, то ответ уже сам по себе становится довольно очевидным. То есть разложив все эти числа, сделав 2 операции буквально, нам нужно найти, что разница между 290 и 110 – 180 грамм, и мы понимаем, что самое главное, это ключевая часть, что у Алана было 1 юнит, да, а у Беллы было 3. Соответственно, это помогает нам уже видеть их соотношение. И мы находим, что 1 юнит 90, половина от 180. А так как вопрос спрашивает, сколько у Беллы было сахара, да, тогда 3. То есть она на 3 умножить, то есть 10,70. Вообще вся суть сингапурской математики, или подхода, скажем так, можно разложить на 3 компонента, или 3 этапа, 3 вида донесения материала. Это concrete, pictorial, abstract, то есть конкретно предметный опыт. Это на ощупь, это когда можно прям пощупать, посмотреть, поманипулировать. Да? То есть в данном случае это можно было прям сахар принести или песок или что-то, и прям с весами это все смоделировать. Так тоже можно. Pictorial – это будет вот это моделирование визуальное, и абстракт – это уже математическое решение, то есть символическое решение. На самом деле дети вот такой язык они изначально сразу не поймут. То есть это мы, взрослые, чуть-чуть. И то даже, например, нам приходится что-то визуализировать. Да? То есть дети сразу без вот этой поддержки, сразу в многоэтапную задачу так вот в голове продумать, ну, очень редко гении так могут делать. Да? Вот основная масса детей так не сможет. Поэтому здесь именно упор делается на то, чтобы изложить визуально и показать. Таким образом, вся методика работает целиком. У нас есть конкретные вещи, предметный опыт, есть визуализация модели и есть абстрактное решение математическое. Оно все идет вкупе вместе. То есть оно как бы нераздельно.
Okay.
Thank you.
So maybe I pause for a moment. Anyone with any question at the moment?
Вопросы в аудитории, в Zoom? They're asking for the what CPA stands for. Maybe I can take this one.
Okay. So CPA is concrete pictorial abstract. Okay, just a minute. Maybe I can share with you.
Okay. Yeah.
If
you have if you have a slide on it, that would be great. Yeah.
So let's see. Now, okay, maybe I will show you this one. Concrete okay, C stands for concrete, yeah, and P stands for pictorial, A stands for abstract. Now, we usually make use of this in teaching all kinds of concepts, especially in the primary school. Like in this case, you see in the picture, the teacher is teaching division, right? We know division, as you can see, maybe you have 20 divided by 4, so the students will start to put in the item. So that is concrete, all right? So concrete is doing. They get to do. What is pictorial? Now, students cannot be just doing, you know, they will be given paper with questions. They have to go for your paper and pen exams. So they have to see it in the form of a picture. So from doing, they will be seeing. So something that they cannot manipulate, they cannot play. They will be able to see only. Then this will be pictorial. You can see in the board, on the board, there will be like pictures being drawn. All right, just now when you have bar model, so this is also pictorial. This one is also pictorial. All right, pictures. Abstract, when the students are writing just the numbers, reading just the words. All right, so that will be abstract. All right, so this abstract here will be interpreting, right, and applying. So interpret and apply. Apply what? Apply the concepts, right? Because first they are just seeing it and doing it, and now I put it into a symbolic representation. So this is symbols, yeah. So this is actually abstract, is symbols. So that is CPA. So this slide here is to show you that in our teaching, right? Now this is classroom teaching. Even in our textbooks, okay, we will have a lot of components to tell students, okay, do this, like activities, and you have a lot of pictures. You see Singapore books, or they are very colorful, or with a lot of pictures. So because of the pictorial representation, then only you see the words, explanation, word problems, the mathematical symbols, and the equations. That one comes after that. So it is always this process of CPA. Bar modeling is also a part of the CPA, the pictorial representation. So if you remember just now the question, because we have that pictorial representation, it becomes easier to solve for a primary school kid. All right, and so that's CPA. And of course, I show you one more picture here. This is the collaboration. We like students to do group work because of the 21st century skills. We want students to not just sit down and do their independent work. We want them to also be able to exchange information with their friends, work together, and learn from each other. Okay.
Awesome. Okay. То есть, чтобы более развернуто объяснить концепцию CPA, здесь пару примеров приведено. Например, на первом рисунке это concrete, то есть это действие, да, doing, то есть действие. Тут ребенок должен что-то делать, то есть взаимодействие с каким-то конкретным прикладным материалом. На данном случае какие-то камешки или что-то цветные, да? Ну, еще какой-то счетный материал у него есть, у ребенка. Теперь в предыдущем примере это был бы сахар, да, или песок, или еще что-то, что можно взвесить. Второй этап – это pictorial. В данном случае это они рисовали какие-то фрукты, считают, еще что-то. Тут не совсем видно, но то, что они рисуют на доске, это уже будет pictorial, да, двухмерное. Это именно видеть, визуализировать. И третий этап – это уже абстракт. Это все, что мы знаем по традиционной математике, вот, символика, да, то есть это числа, знаки, уравнения, там. То есть все, что связано с математикой, это уже будет абстракт. Я бы сюда еще добавил язык, то есть ESL тоже будет абстракт. Да, вот здесь составление предложений, да, и так далее. Вот. Да. Вот здесь, например, тоже использование бар-модели, это что, который вы видели пример, да, с помощью плиток, количественные значения сравнивать. Это моделирование бар-моделинг, это тоже будет pictorial, то есть именно визуализация часть. Также есть, например, где они, например, работают в командах, коллаборируют, что-то делают. То есть это уже опять более прикладное, да, конкретно.
Okay. So now I have two questions on the chat box. Okay, let me answer them. Okay, the first one, can we use this this mathematics in high school as effectively as in primary school? Now, the answer is this. Well, Singapore math, I wouldn't say it's like Singapore math. I would say our way of teaching. Teaching for understanding. Even in the high school, I would still want to teach for understanding. I don't want students to just read that formula, try to remember and throw it back at the questions and work out without understanding. So the idea is still teach for understanding. All right. But if you say, oh, what about CPA? High school students, do they play with the counters and so on? Maybe not. Because this will be very useful for the young kids because a lot of things has to be able to feel it and see it. Is very good for them. When you come to a high school, a lot of the concepts are very abstract. Of course, if the students can do, because they are older now, we will go ahead and go into abstract. But of course, some of them, some of the concepts are too difficult to see. We want to also bring in the CPA. All right, that's for high school. That means high school, primary school, if you teach for understanding and you want to use CPA, they will work. Both will work, but you have to have idea what to do. All right, for example, I would use algebraic tiles. Algebra, we will say, okay, maybe I will give you another example. In this case, I will just use a quick one, a whiteboard. Now, secondary school, yeah. How do I do x plus 1? Let's say x plus 1 times x plus 2. So this is secondary high school math, yeah. So if you're interested, now how do you teach that in your school? How do you teach that? In some schools, even in Singapore, teachers teach procedure. That's how I say, oh, we try not to just teach procedure. We want to teach for understanding. Many teachers would teach this. They say, in Singapore, we call rainbow. Some teachers are, oh, let's this rainbow. Remember, this multiplied by this one, this multiplied by this one, this multiplied by this one, this multiplied by this one. Many students try to remember. So that is also a no-no. We don't want children to just remember, that's rote memory. Do you know why? Why? Why must we do this? Why? Okay, so I will bring the algebraic tiles, okay, put together or draw a picture, all right, or use cardboard and cut it out. Okay, so this is what it means. See, if this is x, if here is x, this is 1, and another one, this is x, and this is 2. Now, this is like finding area, isn't it? So over here, this one is just x multiplied by x, right? This is x, and this is x. So this will be x squared. All right. What about the other side? This will be x and a 2, because it's a 2. So x multiplied by 2, 2x. Same thing, we will do the same thing for, let's say, here is 1, then this is x, this will be x. And finally, we have 1 and a 2, you get a 2. Now, this is actually picture because I'm drawing on the screen. I can bring a cardboard or a tiles to show them, you know, if you put it this way, you're finding the area, that will be the T, concrete. So, concrete and pictorial. Now, this is abstract. This is pictorial. All right. And if you use the algebraic tiles, all right, tiles will be concrete. Now, this is secondary school. We actually do this. So, my time, secondary school teachers will just teach the abstract. We just say, oh, do this rainbow method. But we don't know why. But now, we teach differently. I give you the tiles, I give you the picture. Do you understand now? It's like finding the area. Then now, I will show you a shortcut. Let's do this rainbow method. Okay, so I have CPA. So high school, primary school, all okay. Right? Actually, students love it. But of course, depends. Some concepts, you spend too much time on this. Usually, high school, you have less CPA, a lot of abstract. So our idea is that when the children in the primary school, middle school, they would learn the foundation well because of CPA. When they come to high school, well, their abstract is very good already because of the CPA they learned last time. Okay, so that's to answer your first question.
В общем, вопрос был, можно ли использовать такой же подход в старших классах? Он сказал, что зависит. В любом случае говорит, что в старших классах мы делаем упор на понимание. То есть педагогика старших классов тоже акцентирует понимание. При надобности можно использовать и concrete, и pictorial, но, конечно, больше уже идет на уровне абстракт. То есть вот на этом примере мы все знакомы с этим примером. То есть это где-то 7-8 класс математики, если я правильно помню. То есть здесь именно такой, говорит, чисто абстрактный метод нас обучает обычно, то есть rainbow назад, еще что-то, да, радугой. Но для понимания, чтобы помочь учащимся понять эту концепцию, можно использовать визуальный подход, тоже pictorial, и при надобности можно также принести concrete, например, можно принести такие дощечки, да, плиточки, можно с ними на бумажках цветных можно вырезать. Можно поработать, основываясь на концепции площади, можно прийти к таким же выводам. То есть все равно можно использовать, но, конечно, в старших классах уже меньше на вот эти concrete pictorial, больше на абстракт, но все в любом случае на понимание.
Okay.
Это как в Сингапуре.
All right. So someone asked, what about trigonometry? So I just give you a quick one, right? Trigonometry. Now, if you, of course, for a start, the most basic one, trigonometry ratio. You can get the students to play with a right angle triangle. You can ask them to measure, find the ratio. Usually, we can also bring the students to the computer lab, do that simulation with the shapes and find the ratio. Then they'll see, oh, they all, no matter what length it is, they'll follow the same thing. They have the same ratio based on the angle. Yeah, so that's trigo. Of course, another example is I would bring my students out. Now, this is very common. Once they learn the ratio, they know how to apply. Let's say I will bring the students out and say, look at the flagpole. Every day they have to go for assembly and look at the flag, all right? How tall is the flag? Without measuring, are you able to calculate? Right? We will teach them how to find angles of elevation and so on. Okay. Of course, give them a very simple tool to find the angle. You know, look at the flagpole and from where they are standing. So they will have to find out how what I learned can be applied in a real life situation. Now, that is actually our concrete. Why concrete? Because you have a real life thing, a real life experience, the actual flag, not a word that is written on the book or a picture on the book. You're looking at the real thing and you're supposed to find that. So that will be a good activity for students to apply what they learn, right? And of course, basic concepts. I can cut out a triangle for them to work out. I can use computer simulation tools, right? To find out the ratio. Now, all these help students to learn. I know my time again, traditionally, my teacher will say, please remember, right? I don't know whether you learn this, all right? My teacher will ask me, okay, memorize this. So again, this is the past. So today we don't want just to memorize. We want you to know why. Why is it like that? Okay, so that's trigonometry. Okay.
Thank you. То есть даже такая сложная тема, как тригонометрия, мы можем использовать компьютерные симуляции или же в классе можем изучать, например, свойства треугольника, да, соотношение сторон. То есть независимо от того, от размера треугольника, пока мы угол оставляем одинаковым, то есть мы можем найти, что синус и косинус остаются одинаковыми. То есть мы понимаем, что синус и косинус это функция именно угла самого и так далее. То есть разные есть примеры. То есть любую концепцию можно постараться визуализировать и можно донести более визуальной формой. То есть даже в старших классах.
Okay. So let me go back to the slide earlier. Now, oops, sorry. I think I don't know why I pressed. Okay, back here. Now, one question in the text box would like me to, okay, one teacher would like me to share, okay, very quickly how I get the 3 units and 1 unit. Okay, so come back to this question, just a quick one. This is our bar modeling, which is the pictorial part of it, of our CPA. Yeah? The drawing is the pictorial representation. So how should I do it? Now, first, Alan, right? Alan puts some brown sugar on the dish. Okay, so this is Alan, let's say, and this is the dish. This bar represents the dish. Sugar, okay, this is the sugar. So I use different color or different size to represent. This is the dish, this is the sugar. All right, Bella, okay, Bella tries the amount of sugar on the dish. So Bella will also have that dish. I will draw the same bar. This is the dish to represent the mass of the dish, but the sugar will be 3 times. 1, 2, 3. Of course, I need to put down the numbers. Okay, this the mass here to here, so it weighs 290. Right, and here to here, okay, here to here, this is 110. Now, because our children can visualize, yeah, that means they can see. What do they see? They see, okay, this is the same here. This is longer, right? This is longer. How much longer is this? 2 units longer. So this is the 2 units, right? Unit stand for that box. And what is the value of that 2 units? You can see here to here is 290, and here to here is 110. So this difference must be 290 subtract by 110, because they can see it, right? 110 and that number will give you 290. So if you subtract this out, it will be 180. All right. Now, so that is where I can get 2 units. 2 units is 180 grams. And then, of course, I can find 1 unit by just dividing. So 1 unit will be 90. And the question, now usually some teachers will say, please write down what you're finding. We are finding the brown sugar. So I will have to show that, okay, this is my question mark. I'm finding 3 units. That's what I want to find. So finally, 3 units will be 270. That's how we get the answer. Now you imagine, if I want to use algebra to solve this, of course I can find. Let X be the dish, let the sugar be Y, and then I have simultaneous equation, right? Now, but that is, again, you're in a secondary school. So in primary school, they don't learn simultaneous equation. They will use the pictorial representation of the bar. then they decide, oh, I should now divide, subtract. Okay, so that is how we solve this question, right? This to answer the teacher earlier in the chat box asked how I solve this. All right, you need to translate.
В общем, вопрос заключался в следующем. Попросили более подробно объяснить, как вообще логика выстраивания модели, bar model, и как мы можем учесть вес тарелки. Да? То есть он объясняет, что вес тарелки... То есть тут мы делаем сравнение, да, comparison, мы сравниваем две величины. Это после того, как Аллен положил, и после того, как положила Белла. Ага. То есть вес самой тарелки, он же одинаковый, то есть мы можем поставить одинакового размера плиточку там, и мы знаем, что Белла положила в 3 раза больше. То есть опять мы визуализируем, что там в 3 раза больше, и отсюда мы можем уже потом вычислить. То есть тут вся суть в том, что ребенок такой, то есть ученик такую сложную задачу может визуализировать просто и упрощается именно, то есть решение становится более очевидным после понятия логики, да, логики задания. То есть вот такой визуальный подход позволяет решать довольно сложные задачи, даже олимпиадного уровня, довольно простым логическим путем. Yes, thank you.
Okay.
We have about 10 minutes left, 10 to 12 minutes. Yeah.
All right. So, definitely, I will be able to share more if you have more time. So I just want to, but that example one, actually I have many examples, but this example is good enough to tell you what Singapore math is about. Problem solving, that's number one. And how to teach. The CPA approach is one of the many ways, but there are others, all right? Just to have this share with you, this one here, our job as a teacher here, which means if you're using Singapore books and Singapore, you want to know what Singapore math is about, we focus on problem solving. So we are told that we are teaching math, but we are actually turning our children into problem solvers. We want them to have good and strong problem solving abilities, which is why you will see there's a lot of challenging questions in the books. And in order to achieve that, CPA approach is one way, because we want to teach for understanding, all right? And back to this slide, I will use CPA to teach for understanding, okay? Now, the next one is relational understanding. That means we want them to see, to relate, not procedural. Don't just remember procedure. Remember just now I talked about earlier how you change the mixed number. Those are procedures. We want to show them, oh, this is how it looks like in real life. This is how it looks like in the picture. So we now make sure they know what they are learning. So that's number 2. That's why in the textbook, there's a lot of pictures, a lot of explanation. All right. Now, I jump here. So we focus on collaborative learning because we want students to work together. All right. Again, focus now is on 21st century skills. Right. We want students to not just learn math. We want them to learn how to work together, how to problem solve, how to talk to each other, communicate, right? Communication skills. So there are many. So in the books, you will see that they are activities to help children learn these skills. All right. And finally, okay, I just want to talk about these two. This one will be in our how the books or how the contents are introduced. Variation, number 1. Variation means you see there will be a lot of examples. So when we teach math as well, we're going to tell students, okay, this is the concept. I'm going to show you example 1, example 2, example 3, many different examples. I'm going to show you, let's say, numbers, okay? What is 1 million? I will show you 1 million people. How does it look like? 1 million dots, how does it look like? So many different things to explain one concept. So in the book, you see there will be a lot of pictures. Last one, spiral approach. Okay, spiral approach will be, you will see the book, we repeat the same thing, but every time we repeat it, we will have new things introduced. So if you're doing the Singapore math books, you see, oh, year grade 2, fractions, grade 3, fractions again, grade 4, fractions again, grade 5, fractions. So every year there's fractions, but every time there's fractions, they will say something, they will include something that they learned already, then what is the new thing for this year? So that's spiral approach. So you will notice that we always consider what the children must learn first, then what they learn next. You don't learn everything in 1 year. You learn a little bit. Next time you learn a little bit more. Next time you learn a little bit more. So all this learning theory that's based on research. You can look for the research paper and all this based on this. These are really, really basic. But the idea is we now bring all this into our classroom teaching, into our books. So now students learn, they will now learn with more understanding. Okay, with better understanding, they become better problem solvers. So that's what Singapore is doing, right?
All right. That's a lot. So let me try if I can explain this.
Okay.
В общем, у нас уже скоро время подходит к концу на этой презентации, но тем не менее, чтобы иметь какое-то представление целостное, он буквально вот пробежался по основным пунктам, что именно вот, что мы подразумеваем под сингапурской математикой. Да? То есть в первую очередь мы прошли с вами на примере данной задачи CPA approach, да, что такое CPA подход, то есть Concrete Pictorial Abstract, это три этапа понимания, 3 этапа преподавания. Потом упор на понимание, на логику, нежели на механические, алгоритмические решения, да, то есть навыки высшего порядка, нежели навыки низшего порядка мышления. Потом он сделал упор на групповые парные работы, то есть упор на необходимость развития навыков коммуникации, коллаборации, то, что у нас 4К, да, называется как раз так. То есть навыки, опять, 21 века, то, что в Сингапуре называют навыки 21 века, это вот в современном обществе, да, человек должен быть коммуникативным, уметь работать в команде, да, эмпатия должна быть и так далее, и так далее. То есть это все мы пытаемся даже с 1 класса уже симулировать, давать возможность детям работать в командах, в группах и так далее. То есть в сингапурской методике и в книжках, и в пособиях делается акцент на взаимную работу между детьми в классах. Также он говорит на еще 2 пункта. Это первый – это спиральная программа, то есть это сама, как построена учебная программа. На самом деле очень похожа на наш госстандарт. Новый госстандарт гораздо ближе похож на сингапурский, если честно. То есть тоже построен по спиральному подходу. И книжки также, то есть всегда есть в течение года опять повторение или же укрепление материала, основывается материал на предыдущем пройденном материале. И между годами тоже темы по нарастающей усложняются, но предыдущие концепции ребенок должен знать. То есть там есть четкая спираль. Нарушать ее нежелательно, потому что есть определенная логика, да, спирали, есть определенная методика. Если нарушить спираль, где-то вперед забежать, где-то пропустить, уже вредит процессу обучения. Ну, от вас зависит, от способности детей. Но, да, но методика рассчитана на класс. То есть это рассчитано на массовое обучение. То есть это не репетиторское, это не индивидуальное, это именно массовое. Кабинет 20-25 детей без проблем. Yes, thank you.
All right. So I think there's not much time left. I will go to my last slide. Okay. All right. Now, so I have actually a lot of examples. Okay. Hope that in future I have more time to show you different types of questions. Yeah. But today's workshop mainly focus on having you to understand what we do in Singapore. All right. What is our focus and what we do away and what we are practicing now. All right. So in summary, Singapore math is about teaching for understanding. We don't do rote learning or memorizing procedures. Right? I mean, we still want children to learn the formulas. No, they'll still have to remember, but that shouldn't be the only way. All right. So we should give them the CPA give them a lot of examples so that they learn by understanding. Understanding is the most important, right? Don't just fix on the memorizing. So that is what we are doing now. We always let students do activities. Always let them do something that they can understand what they are doing. So that is the main focus. And so Sanza, maybe you want me to finish up the 3 points, then you can translate.
Yes.
Right?
Yes. Okay.
Okay.
Yeah.
So that's number 1. Number 2, we want to teach students how to fish and not provide the fish. That means we don't want them to find the answer. Yay, I get the fish. No. Finding answer is one ultimate goal. But we want to see your thinking. Show me how you find it. So that is the main focus. We want to teach them how to fish, how to solve problems. We don't want the answer. Answer is important, yes, but I want to know more. How you get the answer. All right. So nowadays, already happening in the secondary school. We have even in the national exam, 1 question, 10 marks. Yeah, is that there's no fixed answer. We want to know what the students are writing. So it's a very open kind of question. Because again, we want students to show us what they are thinking. We want to learn whether the students can think, can problem solve, not just know the answer. So that's the focus in Singapore. And finally, we emphasize on problem solving. As you can see, the framework, the pentagon just now, problem solving is number 1. And also remember, there are many ways to solve problems, not just one way. All right. So all questions can be solved in many ways, and never tell the students, just follow my way. That's the best way. No. The best way is the way that the students can answer and they can understand. Then that's the best way for them. So in Singapore, we focus on all these things. So that's Singapore, right?
Wow, this is great. Let me try to do justice to your explanation. Давайте как бы всю нашу сегодняшнюю сессию подытожим, да, первую сессию нашу. То есть этими примерами, этой дискуссией мы попытались понять основные как бы принципы и философии, да, сингапурской математики. В первую очередь это опять преподавание на понимание. То есть тут важно именно понимание мышления, то есть понимание ученика математических концепций, да, с упором на problem solving. То есть конечной целью у нас является решение задач, но чтобы прийти к этапу, где ребенок может решать задачи эффективно, нужно сперва объяснить через CPA подход, нужно объяснить концепции, да, донести доходчиво концепции. И не делаем упора, не делается акцента на память, на запоминание, на зубрежку, да, упор именно идет на понимание. Нету понятия, что есть только один метод решения задачи. Учитель не пытается только научить вот так вот решать, да, или как-то механически решать задачи. Учитель должен или пытается дать ребенку пространство для понимания математики. И посередине тут у нас как бы вот такая общая философия, нам уже очень знакомая. Не учите рыбачить, точнее, нет, наоборот, не давайте рыбу, а учите рыбачить. Да, то есть, we had a question in the chat about CPA approach. Will we be having the presentation in PDF at some point?
Okay, so I can organize again because I don't think I managed to share everything. So let me cut out the you want the slides, right? So let me organize and then I will send to Lydia. Maybe Lydia can send to you your later today.
Okay. If there's any other chat questions, you can take them, but I think that's all.
Yeah, I think CPA. If you want to know more, now this is not a new concept. You can Google. There are a lot of articles, write-up papers on that. So it is something that is been around for decades. So you feel free to read more about it online.
I just want to thank Brandon on behalf of Kazakhstan teachers. Let's give a round of applause to Brandon.
Yeah, thank you. Thank you.
I just want to say, Brandon, that this was a very great presentation. It gave us a very solid overview of the principles and philosophies and the key methodologies, like approach of CPA approach of Singapore math. This is perfect for 1 hour. This is like as good as it gets. You did an amazing job and we really appreciate it. Thank you so much.
Thank you. Thank you.
So before we end the session, it would be great if you guys could all scan the QR code so we can hear more feedback from you guys on how to improve our future webinars. Yeah. So I hope you enjoyed the session.
Просьба предоставить фидбэк, то есть нашему спикеру, так как это контроль качества, для Marshall Cavendish очень важно, чтобы спикеры были топ-топ, самые лучшие. Соответственно, мы собираем фидбэк. То есть, например, что вам понравилось, не понравилось, да, вы можете, буквально 1 минуту займет на телефонах, пожалуйста, QR-кодом, отсканируйте и фидбэк, если можно. Будем очень благодарны. Спасибо.